And so we have the Standley Lake Stargazing group presenting today. Freddie Cruz, Aric Vyhmeister, and a guest physicist, Ron, will be joining. Aric is not here right now, but he'll come back around 3:30 and join the presentation. So Freddie, go ahead and take it over.
All right. Well, welcome everybody to our meeting here. We're going to be talking about astrology and the myths behind it. And let me start sharing my screen so you guys can see this. All right. Can everybody see that?
Yep.
Yes.
All right. So I just wanted to first send everybody to the chat. If you guys want to see some of the stuff that we put out, we have a website here at www.standleylakestargazing.com. And also, as you can see on the presentation, if anybody wants to open up another browser, if they're on a computer or anything, we ask that you kind of like follow along and you can play around with the Stellarium app. It's free and it's free to use, especially the web version, which is the link on the bottom, the -WEB. And it's good just so that, you know, you can see the same things. We built a lot of the images that we have on here from you know, it's not this one, but it's another software just like it. So if you guys want to follow, we advertise it just so you can see that we're not, you know, we're not getting this, we're not making this stuff up. So you can check us. So we're going to be talking about, again, astrology today. And yeah, so this is June 28th, and I'm Freddie Cruz, and Aric Vyhmeister, he's kind of the one that started. I kind of joined his group a couple years ago. And basically, Aric's a very avid amateur astronomer. He's been doing it like all his life, and he has a very interesting life. And you know, I don't know if you guys remember, we kind of gave a little history in the previous meeting, but he's been doing this for like long time. And we got to know each other through our girlfriends. And whatchamacallit, you know, in terms of me, I'm a space scientist myself. I do machine learning applications for space weather analysis. And so I work in the industry, but the truth is I didn't start looking up into the sky until I met Aric a few years ago. I'd never seen the planets through my own eyes and never owned a telescope and all these things. So yeah, we all have different paths. So that's kind of all I wanted to say about that. Somebody asked about a little bit of our background. So anybody, any questions on that? All right, and just so you guys know, I'm also up north. I'm up in Fort Collins, so I'm a little ways away. So, all right. So here's the Stellarium thing again. If everybody wants to go through that. So I guess what we're going to start by is that I guess we want to kind of give the history of astrology here, and there's a lot of kind of misconceptions that it's kind of like not a real science, and that is true and not true. So the whole thing is that astrology did start as an ancient science, and that's kind of where we wanted to start on the history of this, is that, you know, back in antiquity, the sky was really a mystery. So we didn't really know, we didn't basically have, you know, the ancient people didn't have the science that we have, the knowledge that we had, that we have now to kind of explain the phenomena they were seeing. But nonetheless, they were seeing this phenomenon. They're trying to make sense of it. And so that's basically the first bullet point, is that the cosmos had no explanations, but as they kept monitoring and monitoring, they saw these patterns in the sky. And they noticed that things happened, you know, very often, that there was a periodicity to the events that they're seeing, the phenomena that they're seeing. So one thing that the ancient people, they started seeing through the cosmos, is it became a compass and a clock. So you have it here that the heavens are, some people thought that knowing the rhythms of the sky was a means to knowing, you know, all things, you know, people's characters and all the fate of all things around the world. So as you can see, you know, that's pretty powerful, and it was the key to unlocking a deeper truth. So that's kind of like the motivation behind what astronomy and astrology, which have a common history, that's kind of where they were rooted from. And how this pertained to humans is that a knowledge of the heavens eventually informed the rhythm of our lives, and it created and marked times for agriculture, trade, migration, empires, and war. So that's kind of like the history and the motivation from it. So any questions? All right. Oh, and one last thing I wanted to say is that the astronomers, they considered wielding this information, again, this knowledge, these rhythms, this periodicity, they wielded it as power. They thought of it as very powerful, and the sky was basically their guide through everything. So, um, like I said, that's the history, and that's pretty powerful. And so, basically, what that did is that started to influence culture. And what you have is that a lot of mythology was celebrated through what you were seeing in the cosmos. So as people started to look up in the sky, they started seeing symbolism in it. And in that symbolism, they started tying it to their culture. And that's kind of where like mythology was. It wasn't born, but it was tied into the cosmos. And these stories were used to explain the changes in celestial, phenomena that was going on in the world. And this predates to every ancient civilization around the world. And I read somewhere in some article that one of the most common similarities between every civilization that's ever existed on Earth has always looked up to the skies. That's the one thing we all have in common, is that we looked
So,
up to the heavens and we tried to make sense of it.
Freddie, I have a question.
Okay.
So you're saying that mythology came first and then astrology came along, and what they were seeing in astrology, they just tied the explanations of mythology, they kind of tied it to the astrology?
Not really that astrology. I'm kind of like, this is like pre-astrology. This is kind of like what created astrology. Is that first you started looking at the skies, and then you also had your culture. Your culture is the mythology, right? Because that's how you tell the stories of your culture, is through mythology. And that's again, that's not just the Greeks and the Romans and all these other people, the Mayans and all, that's everybody. And then once you start putting those things together, which is what we're going to get in a little bit in a couple slides, is that once you start combining those things, that's when you start getting astrology. So we're kind of going through like the history of like how it was built, if that makes sense.
Okay.
Yeah, so as you can see there's a picture of Zeus. And so that's just one of one of the examples of the mythology. And one of the things Aric wanted to explain here is there's a famous composer by the name of Holst, and he has this really famous I don't know what you call it. Aric knows the right word for it, but he has a very very famous piece that he composed called The Planets. And basically, as he goes through like the different movements in this um, musical piece, each one is dedicated to a different planet, and he wanted me to play it. Oh, went the wrong way. So that's kind of what's up here. But he said that the one that strikes the most attention is the movement that he made from Mars. And basically, Mars is kind of what we see in like movies. It had a lot of influence in pop culture, mostly with Star Wars, because we have basically like a military movement, and Mars is always the god of war, Ares the god of war, and so there's a lot of connections between there. And so he wanted me to play this, so let's see if this works. Can you guys hear that?
Nope.
No.
I don't hear it. I can see it.
Oh, you can't hear it? Well, maybe we'll put a link down in there.
Or maybe open it in a different window. I'm not sure.
Yeah, I mean, I can hear it through my headphones, but I guess it's we got to work. We would really want to test on if we can embed video and have y'all hear it. So, guess the answer is no. So sorry for that, but yeah. So anyways, the gist that we wanted to get is that with this slide is that again predating astrology is that what's happening is that you have a lot of lore that got placed into the cosmos, and that's one of the precursors to how astrology came to be. So any questions? No? All right.
Nope.
So we're going to go a little bit on the different motions and the type of basically it's like the units of time, the periodicity that we're talking about, the different motions that we see in the sky. So early on, again, we now have a better understanding of, we're the sun is at the center and we're all moving around it, and then the stars are fixed, and we're moving around in what we call like space time. And the whole thing is that back in the ancient periods, a lot of individuals didn't really know. They didn't know that, so they were trying to connect all that, but they did see those same periodic motions. And you see here that we first saw, and I don't know if we've explained it here, but I use it all the time. But does anybody know the difference between how you distinguish a planet from a star?
Twinkle.
Yeah, so usually with children, I say the old nursery rhyme, "Twinkle, twinkle, little star," and I have them recite it. But that is one of the major ways that you can distinguish a star and a planet. But back, if you think about, back in antiquity, back in ancient times of how people started differentiate, they did notice that they're like, okay, these are twinkling, and these are not. They didn't know that this meant a star and a planet, but they made the distinction, if that makes any sense. And they also noticed that the planets moved and they changed positions more frequently, and then the stars in the background, the stars seemed to stay fixed with relation to each other. They still moved in the sky, but in relation to each other, these constellations, these stars seemed to stay fixed. So then they started saying, okay, well, how do we create, how do we make sense out of this? And then that's when they started, again, this is one of the precursors to how astrology was built, and astronomy is that you start noticing, you start writing down all this information and this phenomenon, you try to make sense of it, and they're trying to make sense of it, and that's how it all began. And some of the features they started writing down was the color and how bright things are, how fast are they moving. And one of the examples here that Aric wanted to point out was Mars. So Mars is when you see it in the sky, Mars is very red. It has a distinct red color, and red has always been, in society, red has always been a marker for things like anger and battle and blood and these type of things. That's what we associate with the color red, and sometimes even passion and courage. And so that's why Mars was named after the Roman god of war, is because he was, it's red, and we associate this color red, with these attributes I just explained, the anger, battle, war, blood. And so that's where Mars became the god of war. That's where he became associated with that. But then, that's just one type. So, that's one feature that they looked at. Then you have something like the star of Antares it's a very bright object, and it gets very, very close to Mars. And now you have the motion of a star getting close to Mars. So again, people are trying to make sense of this, and that's why they named Antares the Greek god the Greek god of war, Ares, and he is basically Mars's rival. He is his number one rival. And again, this is all explained. There's mythology behind it, but then there's the association with it in the cosmos, because now they applied that mythology to what they're seeing in the sky, and then those are the stories that keep on telling, if that makes sense. So any questions on that?
I was wondering if there's any other sort of Roman Greek nomenclature like Mars and Antares where they relate to each other, like being rivals there.
Oh yeah, so rivals. I'm sure Eric knows a lot more. I'm not too knowledgeable in that area, but another one is like Orion and his dog. So if you follow the constellation of Orion, his followed, you know, the basically the constellation right behind him is Canis Major, and it looks like a dog. And so the story with that is that, you know, the hunter always has his companion, his faithful companion, his dog, trailing right behind him. So, because, you know, Orion is the hunter, he has the bow and arrow, and he always has his trusty dog, you know, right behind him, which is Canis Major. So there's just there's a whole lot, and then this is just not just, you know, Greek and Roman. This goes in, you know, the Chinese have their own interpretations. The Japanese, there's just so much culture and different versions, and that's kind of where the international committee that they created, it kind of tried to narrow these down and give everybody, you know, their own little voice. For example, Pleiades, which is the constellation you see in the little Subaru. You know, in Subaru's logo is the Pleiades constellation, or the Pleiades, sorry, Pleiades. It's basically, Pleiades is the translation. If you translate it into Japanese, it is Subaru. It's like the direct translation. So there's a lot of those things that you find that have a lot of connection. So another motion that we wanted to talk about was basically Sirius. So back in ancient Egypt, that periodicity that we said that you know, life depends on, is that a lot of the astronomers in ancient Egypt, they were very stuck on on Canis Major, and that's actually where Sirius is. So that's the brightest star in Canis Major, and they would actually use that to predict when the Nile would flood, and that's when they would start all the irrigation, because in that part of Egypt, that's where their life would depend on the Nile. That was their source of water. That was their source of crops and agriculture. So, you know, the ancient Egyptian life depended on the Nile, and they basically used to predict when it would flood, based on the constellations on Sirius. So yeah, there's lots of stories. Like I said, I don't know too many of them. Maybe when Eric comes back, he can give some more examples. But I mean, there's books and there's books upon books upon books of all the stories of the stories reflected in the skies. So yeah, I wish I had more. So, everybody cool? Any questions?
I think today it just seems like the sky is not, or is there's so much light on Earth that we don't see very much of the night sky anymore, and so it doesn't seem so awesome to look at the night sky like it used to for ancient peoples.
Yeah, definitely. Light pollution has put you know, a big damper on that. So, but you know, good things are that we live high altitude in Colorado, to where, you know, if you guys look towards Denver a little bit, you'll see that cloud of light pollution. But up in Boulder, there are pretty great skies, and if you can go camping, that's kind of one of the reasons I want to do that kind of like group meteor shower thing. I would love to do it somewhere like, you know, the Rocky Mountain National Park or somewhere, you know, have a little camping outage, just because like the skies would be beautiful out there, and having a group of everybody, you know, with a bunch of telescopes and all that, that'd be a great thing, you know, that would be a great sight to see.
Mm-hmm.
Hey, Freddie,
Definitely
I had a comment.
Uh-huh.
So the symbol, the Subaru symbol of the Pleiades has, that you'll find in all the Subaru cars, has 6 stars. And we call the Pleiades the 7 sisters. So it's interesting that the Japanese leave out a star.
Yeah, definitely. I actually, it's funny. So there's more to Orion. So Pleiades is actually yeah, Pleiades. Pleiades is actually in front of Orion. And another story with Orion is that he's always following the Seven Sisters because he's trying to, he's trying to find a match, trying to find a lady. So he's always trailing the sisters, but then the dog's always trailing him as his companion. So I also heard something else about Pleiades that ancient astronomers, they used to train their pupils on the Pleiades, and the number of the Seven Sisters, so the seven, how many of those they can see is basically a test that they would do to children, because children have the best eyes, to become an apprentice. That would be their next apprentice, the one that can name the Seven Sisters or see all seven of those stars with the naked eye. So pretty cool stuff. So, all right. Going
I gotta
on.
go. Good to see everybody. Sorry, it's really interesting. Gotta go to another meeting to help out. So carry on, and we'll see you. Thanks for doing this. Thanks, Freddie.
No problem.
See everybody. Okay.
So long. Have fun.
Thanks.
And we'll see you guys. All right. So now we're going to start talking about the zodiacs and how astrology was actually built. But we have to know a little bit of the jargon, a little bit of the nomenclature. So what we wanted to kind of distinguish here is what we call the ecliptic plane. And I learned it as the ecliptic plane, but some people just leave the plane out there and they call it the ecliptic. Does anybody know what a plane is mathematically?
A plane,
Uh-huh.
say,
Like the
two-dimensional
geometric?
figure. Yeah, it's a flat or two-dimensional figure. People
Yeah,
tend to
so
think of it as square.
yeah, exactly. It's a flat surface that extends onto infinity is a plane.
It's this the surface that encloses 3 points.
Yes.
Mhm. Yeah.
So that's kind of the picture we wanted to build here, and that's why they call it the ecliptic plane. Is that if once we're kids, we all see pictures like these, like the inner and outer planets. But when you see them, they all rotate in this really thin line, and we call that thin line the ecliptic plane. And usually when I explain it in person, I call it a tortilla, because like a tortilla, because I'm Latino, and that's what I'm very familiar with. But basically that flat surface is where all the planets rotate about. And that's kind of what we wanted to highlight here, is that all the planets kind of rotate around this very flat, very thin plane. Now, the truth is they're not all exactly on that plane, but that's just kind of like a basic understanding that they're all within this like small little bounds, although space up and down is just as vast as it is, on the sides. And so when we talk about this ecliptic plane, luckily we can see it from Earth, and that's our next slide here. Here we go. Oh, it got stuck. Yeah, sorry guys, I clicked a little too much. All right, so here's the ecliptic plane. So that plane that everything revolves around, if now you take the viewpoint from Earth, and we were all kind of, if everything was in the ecliptic and so was the Earth, we would technically never see anything because we'd all be on the same line of sight. But luckily, the Earth is tilted 24 degrees. And so that's why we can actually see the ecliptic plane, is because luckily Earth is tilted on its axis and not flat, or we would see the ecliptic would be on the horizon. Everything would be in line. And the same, that same ecliptic plane is where all the planets will follow. It's also the path that the sun follows. It's also the path that the moon follows. Again, not exactly, but really close. And you can see it here. I don't know if you guys can read these little markers, but Mars is right here. Saturn is right here. Jupiter is right next to it. And as you can see, throughout the night, they're going to all follow this path in the sky that we call the ecliptic plane.
So Freddie,
Yep.
so we're never going to see a planet like way high up from, in the sky. It's always going to be low on the horizon like this.
No. So this image is kind of skewed a little bit because there are diurnal variations. So the reason why the seasons happen is because of this same axial tilt of the Earth, and it's the reason why the sun. So what happens is that this ecliptic plane will vary during the seasons as well. Sometimes it'll be high in the sky, sometimes it'll be low in the sky, and that depends on what time of the year we're in. And so that will change. And again, early on in the presentation, when I was talking about all this periodicity that we see, that's kind of what gives. We'll touch about this a little later in the once I start getting a little more into the connection between astrology. But there's so many little variations and so much patterns in the sky that it's kind of easy to kind of correlate things because you have a lot of chances to correlate something. There's a lot of change and a lot of patterns going on. So, but yeah, that's I wouldn't say low on the horizon, but yeah, there are times when they're pretty high in the sky in terms of viewing angles, and it also depends on where you're at on the Earth. So the ecliptic does change a little bit depending on your altitude, or your latitude, sorry. So there's a lot of change. There's a lot of variables, and that's where things get a little crazy. But that's why we have this software that kind of helps us with that. So yeah, did that answer your question or?
Yes, thank you.
Okay. Yeah. So the next part is this is the exact same picture as the one before, but what we wanted to show is that now we start outlining the constellations, and this is where you start getting this is where astrology starts saying like, oh, Mars is in Pisces and all these different things. Is that this ecliptic plane and the constellations around the zodiac, they all follow this same ecliptic plane. They follow this same path in the sky. So then that's where the connections start coming across. So, hey, Aric.
Hey, I'm back.
All right, sweet. So I got pretty far.
Awesome. So where are we?
So we're on the ecliptic. We just got through the ecliptic, and we're about to start talking about the zodiacs.
Okay.
So if you wanted to take over.
Sure.
I think everybody's had enough of my talking.
Do we have any questions outstanding that we want to plan to answer at the end or jump in on right now? Let's see, I don't see anything in the chat. Okay. Well, let's just go from there. Let's see. If it's possible, Freddie, could you unshare your screen and then I can share it from mine?
Oh, yeah.
And let's see.
So we did have one question. I forget who asked the question, but they wanted to see more. They wanted to get a little more of the stories that the constellations tell. I basically explained like the Antares one and the Orion, but maybe later on in the presentation, if you have any more, we can share a little more.
Okay. Yeah, that oh man, the night sky is so full of stories and legends and lore that would actually be a whole topic really to cover by itself. There's a lot of significance in that. Let me just show you real quick, since we're thinking about it right now. I'm going to share the planetarium program and see if we can do that. Let me let's see, can everyone see the night sky there?
Mhm.
Yes.
Great, okay. Well, just really quickly, let's just talk about the history of the different constellations. So going back to antiquity, every culture that we know about basically has their own version of what we would call constellations now. Some of them actually view them quite literally as the maybe the remains of the gods memorialized in the sky. Some of them were more metaphorical about it. But the interesting thing is that before these cultures had cross contact with each other, they didn't know what the others were thinking. So some of the patterns that we see in the sky bear a striking resemblance to obvious objects or people that we're familiar with. And so several of them actually evolved separate mythologies that are strikingly similar, and then others are completely irrelevant. So let's start with the most irrelevant constellation. This is Neil deGrasse Tyson's favorite one to pick on. It's called Triangulum, and it's what it sounds like. It's a triangle. Any 3 stars is a triangle, but nevertheless, it got named for a shape. I think it's kind of a cop-out answer, but nevertheless, it's there. So if you know where the Great Square of Pegasus is, or just under Andromeda, that's it right there. Let's turn on labels. That's about all it is. There's no deep history with that one. It's just a triangle. A lot of these have they're just basically connected lines that have myths that we've tied to them, but they don't really resemble anything specific. So Perseus and Andromeda, there's some rich Roman history, I think, there, where Perseus, the hero, is tied to the rocks, and then he's chasing the princess Andromeda around the sky. There's the horse Pegasus. So what we're looking at right here is kind of a modern representation of the constellations. And this was, and we'll talk about this a little bit more, but this is an international treaty where representatives from all over the world got together in 1922 and said, let's just make a definitive map where we agree to include symbology and legends from all cultures that, or as many as we can, and not just leave it isolated to one. And this was mainly to get scientists all on the same page, because when you make observations, you need to know specifically what you're talking about and just all agree on the same frame of reference. So you'll notice that there's some of the more traditional ones like Capricornus, Aquarius, Equuleus, Delphinus, Vulpecula. These are all fairly ancient constellations, but you see them right alongside some of the more modern ones like Triangulum. There's Telescopium. It's more of a southern constellation. Lynx, Cancer, the traditional zodiac, which we'll get into. And these are more or less what everyone uses today. These are the official constellations, and they're actually divided into boundaries, which I'll show in a little bit, so I won't get into that right now. But I just wanted to briefly show you what other cultures use. So if we go to the Chinese constellations, there's a completely separate and unrelated history that has evolved. So you'll notice that the constellations don't resemble anything we would recognize. And I'm actually not really familiar with all the stories behind it. The general principle is that they're much smaller and there's a much more intertwined mythology. Whereas a lot of the Western cultures had like one constellation here, another one here. The space in between didn't necessarily tie in. Where, some of them did, but it didn't necessarily have to. These constellations are definitely more related in terms of the legends, but they're also much, much tinier, and they're more concentrated in the northern hemisphere. The southern hemisphere stars are not visible from China, so I don't quite remember how these evolved. That's a little bit beyond my grasp here, but these orange constellations are the ones that are not visible from mainland China. So I believe they're much more recent and were kind of added in after the fact once Chinese representatives had seen below the equator, which you can't see southern constellations from the tropics. One last point, let me show you Orion. Orion is one constellation that I think Freddie mentioned, but because it resembles a person so clearly, almost every culture that we know of even though they didn't have the same mythology, they all attributed this constellation to a man or a person of some sort, because it's very clearly a stick figure. Let's go back to the traditional constellations. So here's Orion. We have his bow and arrow, the maybe a sword in this hand, the belt, the leg and shoulder, and then the head stars here. And then according to lore, Orion's hunting dog is following him across the sky, and that's what Canis Major is, the big dog. And this is Sirius, the star that it's the brightest star in the entire sky, actually. It's a northern hemisphere star, but it follows. Let me just fast forward time so you can see. This is the way it would move over the night sky. So you can see generally Orion moves east to west, and his dog follows him. A lot of the space in between, though, is not really tied in as well. Like some of these constellations are included after the fact and don't relate to the mythology whatsoever. Interestingly enough, there's Ursa Major, where we get the Big Dipper, Ursa Minor, which is the Little Bear, and that's the Little Dipper as a nickname. There's a couple constellations that share the major-minor relationship. Canis Major is one, but this is one of those, I think it's a cop-out constellation. This is somehow a dog. It's just 2 stars. But if I turn on the illustrations, you can kind of see what their accepted mythology is. So yeah, that requires a little more imagination, I would say. But here's Orion, here's the big dog, his hunting dog, Taurus the bull, a lot of the zodiac constellations that we'll get to. So yeah, there's a lot of history, and there's really no reason it evolved this way. It's more or less arbitrary convention, but we had to settle it out so that we all are looking at the same map, basically. Not actually that much different than if you look at a map of any country. There's a lot of politically driven boundaries that have nothing to do with the actual geography, but you just have to agree on something, and that's how the sky looks. Okay, so let's get back to the zodiac. All right. Does that show up?
But Aric, did each of the cultures pretty much develop a constellation for each of the months of the year? So there's a certain number of constellations that each of them kind of represent. Is that true?
Every culture handled it a little differently. Because there's no natural or obvious or maybe intuitive boundaries in the sky, not every culture handled the divisions equally. So we come up with like the modern division of a month. There's really no reason we would need to say every 30 days roughly is a division. That I believe more or less evolved because the lunar cycle is 29.5 days. And so it made an easy marker where we could say, let's divide that. But there's no real reason we would need to do that. The important things are when the year resets. So when the sun reaches its highest point for the year or the lowest point, either one of those, the solstice is a good marker. The term solstice actually means sol is Latin for sun, and then stis is, it evolved from the root for static or stationary. So it's the day when the sun appears to go down, sink, and then on like December 21st, it appears to stop for that one day, and then it reverses and goes back. Same thing happens going to the top in June. Those are distinct markers, but some of the others just are not really, they don't have a natural derivation. So that's just kind of something that evolved in different cultures. Different cultures like Mayan timekeeping is famously different than anything we would recognize in the West. And yeah, when it comes to dividing the constellations, there's actually a lot of overlapping boundaries. Some star groupings are so clear that, like Orion is a great example, where nobody attributed that to a larger constellation, or it just seems to almost include its own obvious boundaries. But some of the smaller, fainter ones, they could have been drawn any which way, and they don't necessarily, they might overlap depending on which culture you ask. Some like Hydra are very long. Hydra is the water snake. it wraps in and around a bunch of constellations, and that wouldn't necessarily be obvious if you were starting with a picture of the night sky and just connecting dots. You could have done that any number of ways. So does that kind of answer your question?
Yeah, you know, I may be thinking more along the idea of a zodiac that does go monthly, and does that cross cultures as well?
Okay, I see what you're asking. Let me go on a little bit here, and I think I'll hit on what you're talking about, and we can come back to that. So let's check in at the end of the next set of slides here. I think Freddie probably covered this, but yeah, the zodiac is the constellations that lie along the ecliptic, which is the path that the sun takes through the sky. And because all the planets are more or less in a similar plane, and we are on the Earth inside of that plane, it appears as a line when we project it on the sky. It's not exact. They do have an inclination, so they're not like perfectly on top of each other. There's a slight angular difference, but you can see like Saturn and Jupiter are close to the line. Mars over here on the left, it's not quite on the ecliptic, but it is very close. So how do we get to the zodiac? The zodiac is now, I mean, we've already said it's where the sun passes over the course of a year from start to finish, and it returns at the same point. This is just a wide out view. We're seeing more of the wraparound. If you could kind of stand above the Earth for a second, the north and south poles are at the top here. And then this is the standard map that we use to map out the sky on the celestial grid. If you look close, you can actually see some months: April, March, February, January. It's real tiny print, but that is the marker, the tick mark where the sun would be in the sky at that point. So let's talk a little bit more about the boundaries. Historically, what astronomers, and we're kind of blurring the lines now between early astronomy and astrology, because it wasn't as clear back then when astrology had a lot more validity. Astrologers just divided the sky into equal increments 30 degrees apart, and that is not quite the case. So what happens here, I mentioned the treaty in 1922, that was by the International Astronomical Union. We come up with 88 constellations, and the boundaries are marked out here. I've only included the constellations in the zodiac that are labeled, but the boundaries are just like basically like a zoning map in the sky. You can see they're generally not, they're either curves or little segments. They're not as weird as you might expect, but they're very clearly defined boundaries that we use to keep track of celestial real estate. If you want to do some extra reading, you can actually go to the IAU's website, and there's a whole write-up on the convention and how they tried to incorporate the influences of different cultures in coming up with this map that would represent astronomers from around the world. So the problem we have is that the zodiac historically has been divided into equal degrees or equal segments of 30 degrees in the sky apart. That makes a nice alignment with the months. You get 12 months, each 30 degrees, pretty simple math. In reality though, the way the constellations are drawn, they are not of equal size in the sky. So I'll draw your attention to Sagittarius down here on the left. You can see that the ecliptic passes through that. So this is the path the sun takes. That is a much, much larger span than, say, excuse me, the little wedge here where it passes through Scorpius, which is also one of the historical zodiacal constellations. They're not equal. So the amount of time that the sun spends in any given constellation is unequal. So when someone says that their sign is such and such, what that is coming from is historical association with the 30-degree increments. So when they say I was born on this date range, and from this date range to this date range, if I fall inside of that, I'm a Sagittarius. If you look at the divisions on the calendar, they're all of equal size. They don't take into account the modern reconciliation here. So there's a different set of definitions that they're using. And in fact, you've probably never heard someone say that their sign is Ophiuchus. And the reason for that is that it's the 13th zodiacal constellation. And so I'll point out a distinction here. A zodiacal constellation is the official term that astronomers use to describe the constellations that the sun passes through. Astrologers would use the term zodiacal sign. So we have signs and constellations. There is no Ophiuchus sign because it wasn't, the way it was drawn historically actually started above the line of the ecliptic, and this was considered to be part of Scorpius. And you'll see if you took out this line, can you see my mouse? Is that coming through? I don't know.
Yes.
Okay, so on the right-hand edge here, if you just got rid of that and then extended the boundary of Scorpius over here, that's much closer to being equal with the span of Sagittarius. But the way that the modern constellation is defined, Ophiuchus actually encroaches past the line, and then they're just left with this little tiny wedge of Scorpius. So this would be, I believe, somewhere around November to December. There's actually a period where the sun passes through the 13th zodiacal constellation, but astrologers have not even attempted to reconcile that. They still stick with the 30-degree equal signs of the zodiac. Let's see, let's pause there. Chuck, did that kind of?
Yes, thank you. Yep.
Okay, all right. Okay, so next topic here. As Freddie's talked about, there are a lot of real terminologies that have been borrowed from the science of astronomy that astrologers tend to use. And it's not always clear what they mean, but I'm sure we've all heard somebody say that Mars is in retrograde, therefore something's going to happen. What is going to happen is not really as important as noticing that Mars is in retrograde, and it's usually said with some sort of negative connotations. So I want to talk just a little bit about what that actually means and why there's really no significance to it, but it is a fascinating byproduct of orbital mechanics. Retrograde literally means going against the direction of motion. In orbital mechanics, you have retrograde to mean going back. It's posigrade, going forward, I believe. Most of the time when you watch the planets traverse from night to night, you'll see there's very small increments. And if you take a tick mark on its orbital path against the night sky, you'll see that it's making nightly progress in one constant direction. This baffled the ancient Greeks, though, because there was one point that the interior planets, Mercury, Venus, and Mars, they're all on the inside of the Earth, if you remember from the picture. For some reason, they appeared to stop moving for one night, and then the next couple nights they would go back, then it would stop again, and then it would start going forward in the direction they expected. And Jupiter and Saturn, they didn't really notice that effect, and they're further out, and there's a couple of reasons for that. But the interesting thing is that they felt like something must have caused the motions of the planets to stop moving or somehow go back, and they couldn't conceive of a rational explanation why this would happen. So they immediately went to superstitious paranoia and wondered maybe this is a sign from the gods or something. And it's not a very common effect, and so they didn't really know how to predict it at first, and it seemed very spooky. So I want to talk about what this is and what's causing this to happen. What you're looking at right now is the path of Mars, and this is a typical progression. So you would start on the right-hand side of the screen, and you can actually kind of see there's some very faint tick marks. It's probably not as clear. The little bright points here, I'll try and highlight. This would be the nightly motion. If you were to plot it every night on a star chart, this is what you would see. And then this red line is obviously just interpolated between them. So this all makes sense. It's moving west, and that makes sense. Or sorry, east. And then this weird little curve happens. So I'm going to show you one picture that is going to explain about 2,000 years of confusion. Once we understood that the planets are actually moving around the sun and not Earth, and that's a whole other discovery, but we'll just take it as understood for this discussion right now. Let's pretend that T1 and P1, this is Earth on the left, and this is Mars on the right. P1 is Mars. So I'm showing you the exact same picture as this. We're going to start on the right-hand side of the screen. Okay, so this is what Mars projected against the background stars would look like. Now the stars are so far away that effectively they appear to be at infinity, meaning they don't move from night to night. We can't detect any parallax or shift with our perspective. Now, when you draw a line from Earth to Mars and then see where it lands on the constellation, that's point A1, that would be kind of the right-hand edge of the screen, like right out here. Now, what happens is that as we start to overtake Mars on the inside, a curious thing happens. So Mars moves ahead, and we're lagging a little bit behind, and so it seems to move to the left, which makes sense. So the first point, A1 and A2, those make sense. It's moving in the direction we expect, and nothing weird happens. Now, as we start to overtake Mars, we're in line with it directly. Look what happens when we draw that straight line out. See how A2 is actually further ahead than A3? And as we continue to overtake it, the path appears to go back just a little bit, and it's purely a trick of perspective. And then as we continue on around, now it starts to move forward, and that's where A5 is. So looking at this picture again, on the right-hand side, we're coming up on it. We're both moving in the same direction. Then when we get out here, we're starting to get in line with it, and we're overtaking it, and so we appear to make it move backwards. So it's really us that's causing the shift in perspective. This is almost directly analogous to overtaking a car on the highway. Let's say you're passing it a little bit quicker on the left-hand side. Relative to the mountains behind it, as you overtake it, at first you're both moving in the same direction. You don't see anything strange. But as you get close to that car, you start to notice that if you look through the windows, it almost appears to be moving backwards relative to you. And then if you get significantly further ahead of it, now you both appear to be moving in the same direction. It's a similar trick of perspective that creates the illusion that the object that you're overtaking is momentarily going behind. Yeah, let me just pause for questions there. Does that make sense? It's a little bit heady, but I think it's very fascinating.
Yeah, I guess to everyone out there, I guess one of the points we're trying to make is that there is science. There is, actual like perception like this. This is something real, that's rooted in astronomy. This is basically the science behind it.
Yep.
I think
Yeah.
I mentioned a
Go
while
ahead.
ago to you that I saw basically a time-lapse picture of the planet, and then the next day it moves, the next day it moves, and then it's going backwards for a while because they just took a time-lapse picture or a picture at the same time of the day of the same spot. And that was the first time I'd really seen what the retrograde motion meant, that I've heard about forever, but never really saw it before. And this is neat to see it this way too, that's for sure.
Absolutely. It's also worth noting that this is purely because we are on the surface of Earth. There's nothing absolute or universal about this. The effective motion would be slightly different if you were on the moon. So an interesting thought experiment from an astrological perspective would be to say, which is binding? Did the Apollo astronauts experience a different retrograde because they were viewing it from 250 million miles away? It would not be the same. It would be close, but it wouldn't be identical. And, if we're assigning major significance or some sort of superstitious connection, it would be important to understand which of these we mean. And down the road, what if we're able to ask from the surface of Mars itself, what if the Earth is in retrograde? I mean, there's nothing physically that would prevent us from seeing those same behaviors. We know that's true. I mean, the orbiters or space probes that we sent can observe these orbital effects, but they're purely because of perspective. And assigning perspective any sort of life significance is not really a defined concept. It's kind of just because it's a very, I don't know, retrograde and conjunction and other orbital geometries, they sound more complicated than they really are when you see a picture that explains it. And it's one of the things that astrologers like to rely on, is obfuscating what's happening and making it sound a little bit more mysterious or technical than it really is, so as to elude any sort of line of questioning that might reveal the game. Okay, so Age of Aquarius. Yes, question? Oh, I think you're on mute.
Can you hear me?
Yeah.
Yeah.
as humanity moves to populate Mars in the future, will people living on Mars want to create whole new meanings or constellations because they're going to have a different view, right?
The planets will move differently. The constellations will essentially be the same. I mean, we have equipment now that is fine, has high enough precision that we could actually detect a slight difference in the parallax of the nearest stars, but to the unaided eye, it's absolutely imperceptible. However, the motions of the planets will appear different because you're standing an appreciable fraction of the distance closer to some and further from others. So you would see, for example, Mercury and Venus would be a lot closer together. They wouldn't move nearly as far apart from the sun because Mercury and Venus, they're bounded on an interior orbit relative to the Earth. So we can only see them stray only so far on either side of the sun. But then you go to Mars and that distance is now like this. But the behaviors are still going to be the same, except for the Earth, which you wouldn't be used to seeing on the surface of the Earth, obviously.
So because the stars are so far away, moving to Mars is an insignificant difference in perspective.
Absolutely. It's more or less on par with looking at, let's say, Pikes Peak and taking one step to your left about a foot apart and then seeing what that difference is. It's technically there, and with high enough precision instrumentation, you could probably measure that out. But would you be able to detect it? Absolutely not. It would be essentially at infinity for all practical purposes. But you would notice the objects 20 feet in front of you slightly different.
Right.
But one change would be the moons. Like, we only have one moon, but Mars, you would definitely see more than one moon, and that would add complexity to your, to your determination. So,
absolutely. And Phobos and Deimos on Mars, they're much closer. They're basically asteroids that somehow got trapped in orbit, is what I believe the more modern understanding is. And they are not in tidal lock like our moon, so we're always looking at one face of it within about 10%. And Phobos and Deimos are constantly rotating on their own axes, and they're much, much smaller. So you wouldn't see that the moon, our Earth's moon, is actually in some ways an anomaly because it's by far the largest planetary satellite to satellite ratio. The moon's size relative to the Earth is much, much larger than almost any other planet in the solar system. It's, I believe, a little larger than Europa, which is a moon we can see around Jupiter with even primitive telescopes here on Earth. The 4 Galilean moons are very substantial, and yet our moon is significantly larger. Most of the other moons are trapped debris of some sort. Okay.
I had a comment for Cheryl's question. There is one viewpoint that we have, the New Horizons spacecraft, the one that took our first close-up pictures of Pluto. It's now something like twice as far away from the sun as Pluto, and it has a star camera, and it looks out at the stars, and the very nearest stars like Proxima Centauri and Alpha Centauri are seen to shift. You can actually fairly easily see the shift in those stars against the background of even further stars. But that shift is relatively tiny, so all the constellations, even twice as far out as Pluto, look essentially the same as they do from Earth. So that's how far you have to get away from the sun in order to see any significant shifts in the stars in the constellations.
It still amazes me a bit that the ancients could have a record printed in their mind, something of the star chart, to be able to see on a daily, weekly basis how the planets are moving through it. How accurately they were able to do that without taking a picture of it every day or having on a nice white piece of paper and plotting it. They must have had some interesting tools to record that.
Yeah, I have a renewed appreciation for their diligence every time I'm out with my very fancy modern telescope. I mean, by modern standards, it's not much, but considering how far we've come, I mean, in the last even 100 years, I should have no room to complain about how hard it is to keep track of things. And yet it is fairly tedious, and there's not a lot of forgiveness for error. So that just magnifies their accomplishments that much more, I think. It really was a real great feat.
Yeah,
What
I
we're
think
looking
they
at on the
said,
screen here is the New Horizons probe, just as it moves out in simulated time. Go ahead, Freddie.
oh yeah, I just wanted to point out from my readings, my research on this is that they said the ancient Chinese were by far the best at documenting all this phenomena that they saw. You know, from solar eclipses to all the stars, the constellations, comets, and everything. They were by far the best record keepers.
Yeah, and I remember reading too, they also had, because the ability to predict eclipses was so powerful, they wanted to kind of portray it as a supernatural event and somehow, you know, use it basically as a large scale magic trick to say whatever superstitious reasons you want, on this day this is going to happen, and if this happens then you should believe us because we have revealed knowledge. And they had the ability to predict eclipses very accurately, and so they could tell months out this will happen, and then they used it as a very, very effective ploy to I guess demonstrate their power or some sort, or suggest they had much more than they actually did. Just for comparison here, this is where the New Horizons spacecraft flew out, and you can see how at the beginning it was moving much, much quicker. And this is just crossing the orbit of Uranus. And just to put in perspective how slow the outer planets move, you can see Uranus up here, Neptune is just crawling along, and there's the Earth. Every one of those revolutions is a year for us. And look how little it moves. And obviously there's Pluto way out there.
They look so circular. Are they? I didn't know the orbits were that circular.
They are very, there's a very small eccentricity. At this scale, it's hard to see. Let me go a little more edge on, and you can see that they are more elliptical, but they're not quite in line with each other. So as we go edge on, you can see that they don't all quite land in the same plane, but they're close.
Yeah, most of the orbits are pretty circular. They're, you know, you're talking eccentricities around like 90%. So
yeah, very, very close. All right, let's go to the Age of Aquarius. Everyone's heard the song, I'm sure. And this gets tossed around in astrological parlance quite often. But what exactly are we talking about? So what happens, the ages of any sign, I guess you could say, astrologers define the constellation that the vernal equinox, the spring, the first official day of spring, they decide that for whatever reason, that wherever that falls, whatever constellation that happens to be in, that is the age that we're currently in. Now, every year, we talked about solstices and equinoxes. Solstice is when it's at the highest or lowest point. The equinoxes are directly in between, and actually the name is Latin for equal night, equinox, and that's where the day has a night that is essentially of equal length. It's not quite exact, but for practical purposes, it's roughly half. It's a reasonable enough consideration. Now, the Earth is spinning on its axis, and the axis on the top here, that's the North Pole, that points to the North Celestial Pole, which in North America, we all know is very close to Polaris. But that does not actually stay the same over time. There's a curious effect that happens when you have a gyroscope, any mass spinning about its axis. It tends to precess, which basically traces a loop around. So you can see this if you spin a top on a table, it won't stay perfectly still. It'll induce a minor torque, and then that will cause it to rotate on its axis a little bit. It's much slower, though, than an individual revolution. So this effect on the scale of the Earth causes it to trace out an arc in the northern sky that takes about 20,000 years or so to see. And because of that, it shifts the point where the solstice happens by a very, very small amount each year. So the point that we define as the vernal equinox, which is where the ages are taken to be defined as for no particular reason, that shifts ever so slightly from year to year. I'm going to show you a grid here. This is the point in the sky that the sun crosses in the top left here. That's the summer solstice. The summer solstice is, even though we say it happens on a day, it's actually an instant of time. It's only crossing it for an infinitesimally small moment, and then it's done. And that's when the center of the disk of the sun crosses this intersection in space. There's another point where, well, actually all four. There's the vernal equinox, the autumnal equinox, and then the winter solstice. And they're all separated by 90 degrees in the sky. But that point that you see here we'll just use the summer solstice as an example, that would move ever so slightly, a small fraction of a degree every year. Now, and if we zoom out, you'll see that there's constellation boundaries, and it will be in that constellation for a very long time, but every 1,000 years or so, it will technically cross into the next one. And so that is what they mean by age of Aquarius. Once the vernal equinox inches forward ever so slightly and crosses the boundary into the formal constellation of Aquarius, then it gets into some weird stuff. There's all sorts of beliefs about what will happen, some sort of age of enlightenment, and those things that we're not really sure where that got agreed on, but nevertheless, the definition actually is somewhat grounded in modern scientific definitions. Let's see. So we've kind of talked about the history of astrology. We've talked about how it started to deviate from modern astronomy and how astronomy kind of provided better answers for things. And so you could think of astrology as more of a vestige of modern science. But as it pertains to what people practice in modern astrology, when they say that they're checking their sign or checking their horoscope or trying to do some sort of meaning, we have obviously no basis for that, but there are some questions we could ask about how that mechanism could work. So we've talked about definitions of constellations, where those boundaries are. We've seen that those are essentially arbitrary, but we all agree on them. And arbitrary is not to mean that they're loosely defined. They're very precise. This is very scientifically defined and constrained, but it is by convention only. There's nothing in the universe that makes that obvious. And in fact, if we were to find all of our institutional knowledge was to disappear overnight and we had to reconstruct everything we knew from scratch, there would be no reason to expect the constellations to be redrawn in the exact same way, nor the boundaries in between them redefined in anything similar. So we're dealing with basically man-made conventions. So that's one interesting point. Also, this all takes place on the surface of the Earth, which is not a point in space. It's a point that revolves around a body, which is moving through space. And that changes very slightly, but not zero, the perspective effects that we're seeing. So when you say that your birth takes place on a certain day, questions you could ask, like, what if somebody is, like, two people are giving birth within 10 feet of each other on either side of the international date line? Is there anything to think that their signs would be different just because of that arbitrary distance, or is there anything that is actually happening there? So those definitions. Oh, and another really important question we would need to ask is, when we talk about time scales and measurements and definitions in time, we also use several different calendars. Astronomers tend to use the Julian calendar, but there's also the Gregorian calendar and a couple of variations on that. They're called epochs, and that's beyond the scope of this discussion. But astrology seems to just assume that time is one universally understood metric and it doesn't change. There's no room to debate, when in reality, there's a lot of conventions that have to be considered. And for example, when we add leap years in, those are not arbitrarily done. Those are done to reconcile our system of timekeeping. But again, it's man-made convention for the sake of organizing our observations and schedules, but nothing directly spooky about it. Now, if let's just say for the sake of argument that there might be some sort of influence that's happening from the stars. Well, the only way that we know of that any influence can be transmitted at a distance would be through gravity. And we know that this is a measurable phenomenon, and the gravity of the moon and the earth and the sun are far closer than the minute gravitational influences of the stars or even the outer planets. And I've heard arguments that this is really not the mode of transmission, that the influence is carried on. And you start to realize that the definitions are so broad as to be unenforceable or unfalsifiable. And it's hard to even understand if there is a particular claim being leveled, or if it is just deliberately evading a definition so as to not be pinned in a box. Same thing when it comes to predicting a successful outcome. Astrology in some ways is unique because it considers the person, both the client and the answer key, because you go into an astrologer and they ask you if they're right, but then they turn around and offer you advice, and it's only as good as your willingness to believe in it, but you are the one that determines if it's valid, and then instantly switch roles to say, okay, I've determined that you've passed this test, but now I need your information. And you're assuming that all the information up to that point will be accurate, even though you've probably gone back and forth with some guesswork. They've probably asked you some things that were true, some things that were not. Our bias as humans is to keep track of the hits much more than the misses, and assume much greater weight to that outcome. It seems really in a lot of ways astrology stands out from the modern claims. Like flat earth is a great example, because they pose a hypothesis in their title that the earth is flat. So there's a specific idea that can be debunked pretty trivially, but astrology is intentionally vague and elusive about that. And in some ways, if you were getting closer to a specific claim, it would be much easier to see the game, I guess. It's kind of like if you took a barrel of alphabet soup noodles, threw it out on your driveway, and then asked someone to spell check it. It's hard to really understand what the point being made is, much less how close they are to making that. You could almost read just about whatever you want into some arbitrary coincidences. So that leads us, I guess, to where modern astrology is kind of on its own. It bears very little resemblance to modern astronomy. It does often traffic in terms that we're used to hearing from science. It doesn't necessarily relate to those definitions the way that scientists do, but there is a rich intertwined history between the two, and that's, I think, where we can leave it. And I think we should open it up for more questions at this point.
Can I say something?
Yeah, go ahead.
It's kind of like, religion, when religions were created, and then maybe you discovered things scientifically and you don't need that religion to explain anything anymore. You still want the religion because there's so much culture and history tied to it, and it brings you meaning. Astrology was created when we didn't understand a lot of things scientifically. Now we can explain things scientifically, but a lot of people just cling to that astrology because it's part of the culture and gives them meaning.
Yeah, I think the root here is that, like, the belief system behind astrology, like, that's the strong part, and that's also the part to where it derailed from astronomy. Again, just like you explained, back in history when we didn't have proper explanations, they were kind of tied. And, astrology has, been dealt some big body blows, with precession and, when Pluto was discovered and things like this. And then, like I said, then it started derailing. That's when it started going more into a belief system than actual observation. So yeah, you're pretty right on.
Yeah, if we go far enough back in history, there's definitely a point when astrology, or what we would call astrology now, was valid. I mean, it provided better answers than just blind guessing, and things like, keeping a calendar with the movement of the stars. That's very valid, and that was not wrong to notice that. But as we advance the timeline forward and our sphere of knowledge expands, then we start finding some holes in the logic that it can't fully explain. And so we find it's more of a vestigial belief system that was good up to the point that it was valid, but now our answers, or I guess our questions into the natural world, are happening at a much more detailed level than that explanation can account for. So the process of science is just constantly finding a better model. And this goes up to the modern day. Before we had modern physics, quantum electrodynamics, we were left with more or less Newtonian explanations for how things worked, and we couldn't fully explain even the motions of the planets until we had an understanding of relativity. Maybe at some point we could talk about the transit of Mercury. We actually were never able to fully explain the orbit of Mercury until we understood the theory of relativity. But the best model that we had was Newtonian physics, which is several centuries old. And it got us close. And it's not that it's invalid up to that point, but it's that it doesn't fully explain the picture that we have. And so once we have a better model, there's no good reason to stick with an earlier model when we have better answers. And astrology, I don't even think that it's, in a modern sense, it's not trying to offer anything scientific. I think I would describe it more as a spin-off of mindfulness practices or some sort of meditation, but it's very careful to not make predictions or claims about the natural world. And I think it's very aware of its limited territorial boundaries when it comes to science.
Your graphic there showing the planets, how circular they are, you can sure forgive the ancients for thinking they were circles. And then be amazed that without telescopes, mere 300 years ago, they were able to deduce the fact that they were parabolas, or ellipses, I'm sorry. And that difference is mighty small, and you give a new appreciation for how observant they were finally at that point to make that change.
Yeah. The orbits were actually computed to very high levels of certainty, even with a geocentric model of the solar system. And it's funny how when you have the big picture, it's very easy to look back and wonder how that was ever uncertain or a mystery at all. And yet we had the wrong model of the solar system, thinking that we were the center of not just the solar system, but the entire universe. And yet that didn't prevent us from getting accurate predictions about the planets. But now when we understand that it's actually the sun that's the center of the solar system, and the solar system is just a very small system of celestial bodies rotating in a much larger galaxy, then we start getting better answers. But we're kind of, in a way you can think of it as the questions that we're asking keep getting chopped in half or smaller as we go. Like the more certain we become, the smaller the questions we have to ask about how to improve. So now, in modern science, we're not asking big questions about how the Earth moves. We're asking very small questions about the smallest particles and the smallest changes in their motions and behaviors. And it's a testament to how far we've come, but we are constantly improving, and there's no obvious finish line. We have nothing in the universe to suggest that we're even owed an explanation. There are things we may never understand. We may be able to understand, to the best of our knowledge, what we think is everything. We just don't know. But that doesn't prevent us from continuing the process of questioning everything and questioning it again.
So Aric, what do the flat earthers, how do they explain this orbital rotation of all the planets around the sun?
I'll let Freddie answer that. He's, I think, looked into it a little more than I have. I can't say I know what they think about that, actually.
Yeah, so it's funny, we talk about like the flat Earth. I've been fascinated with flat Earth, not that I believe it or anything, but just the thinking and the foundation behind it. But it's similar to astrology that like there's no one consensus on anything. Like some people think there's a dome, that's encapsulating our atmosphere. And then there's other ones that think like the sun and the moon are right on top of us and they're spinning, and the ice wall, and they're all over the place. But the whole motion of the planets, some still, I think the leading theory for them is that they're still in an Earth-centric model. And that Earth-centric model still predicts correctly the motion of the planets, even though it's wrong.
Well,
Or,
with all
you
these
know, that
advances we've
science.
made, there are still some gaps for the theist to insert God into.
Yeah.
I've heard that, and Freddie, tell me if this is wrong, but I believe the flat Earth community is under the impression that there's some sort of projection or screen or dome or something above us, that like the stars are not actually points in space, but somehow kind of a Truman
They're printed
show.
on a dome. Yeah. So that's that dome. Yeah, there's like, it's basically like a
snow globe.
hemisphere. Yeah, like a snow globe, but half a snow globe. And then some think that the Earth, actually, the sun and the moon are inside the dome. And then there's another group that thinks that like the Earth, the sun and all the planets, or the planets still orbit the sun, but then the sun and the planets orbit Earth. And like I said, you can make it work. And you can still predict all the like positions in the sky and all that stuff work, even though it's kind of like a misconstrued version of it.
Yeah, I think
It's when you go to things like, you go to things like solar eclipses and lunar eclipses, and you look at all the phenomena, not just the position of the planets, but also all encompassing, that those things start falling apart. But that's when they'll deflect and go to different areas. But it's like I said, I'm sure they're pulling back some of the history, like just like you said, Aric, like back in the day when they were like, okay, the Earth was the center of the universe, like how do we make this work, or how do we describe this? And they made math that fits it. Mm-hmm. And they're going back to those times and saying, oh, this was valid, and it's like, no, it's not.
Yeah, I think it highlights the slippery slope of picking any conclusion and working back from that. And the scientific method is very, very diligent about not clinging to a belief until it has been vetted and vetted and vetted against every possible line of attack. And most importantly, it's bounded at that point. I mean, we still, the highest level of a belief, we go from hypothesis, and then we test it in an experiment, we draw conclusions. And if we have a working model, a model's value is only measured by its ability to predict. So the better it's able to predict something, not just fit something onto, retrofit onto past observations, then we give it more credence and reputability. And the highest level is a theory when we have not found any way to invalidate it through any line of reasoning or attack. So that's why we call it the theory of gravity, because that's the highest level of certainty we have that that's it. But it's always open to inspection and revisiting. And we're still finding new things about it all the time. Newtonian mechanics did not understand the relationship between mass, time, and gravity, which is why it was only able to explain planetary motions on large scales. So, Jupiter, Saturn, Mars, they're far enough away and heavy enough that we can get fairly accurate with it. But as you get to Mercury, which is so close to the sun and in that gravitational influence of the sun, it experiences an effect that's much stronger proportionally than anything that we would feel on Earth or in the outer planets. So we couldn't fully explain those slight, erratic, unpredictable areas of its orbit until we had a model for space and time through relativity. And once you combine those two, now we have a working model that accounts for the full range of precise observations. But that is still being revisited, and we still want to understand more. So we're very careful now to not put a period where we should probably put a question mark, even in the best of our working models about the universe. And flat Earth, I think there's a lot that could be said about it, but probably the the most fundamental flaw is that it has started with a conclusion, and it's now cornered itself into this tiny box of having to retrofit every observation into a foregone conclusion. And in science, we're just saying, we don't know where this is going to go. Let's let nature take the wheel and see where it goes. And let's just take careful records along the way.
Yeah,
I had two things.
even the waxing and waning of the moon, doesn't that prove? It shows the curvature of the Earth, right?
It can. Well, I was just going to add, we can see, because we're close enough to the moon. So if this is the moon over here and this is the Earth, if you take measurements of the moon or observations from the North Pole, then the South Pole, you can actually detect a slight shift in the features you're able to see around the limb. So I don't know that that would constitute proof for a flat earther, but it is definitely an observable effect.
Yeah, there have been videos that say that the flat Earth model of the moon and how it is, that you actually wouldn't see the moon. It's not a perfect sphere, but it would be more oblong. It'd be more elliptical, like depending on where you are on the Earth. And so that's like one of the things that they try to debunk them. But I just wanted to get back to like the nomenclature of the scientific method. Is that the word hypothesis is, I think, used wrong a lot now in modern society. Like we always say that, like, oh, I have a hypothesis about this, or no, I have a theory of this. And that word theory should really be hypothesis, because a theory does have evidence behind it. A theory is not a guess. A hypothesis is the guess. And that's where I think a lot of things kind of get misconstrued. But going back to astrology, it's kind of crazy that the belief system behind it is still like prevalent till this day. And we're talking about the lunar cycle. The modern day stock market is still to this day influenced by the lunar cycle, the astrological lunar cycle.
It is. How?
It's pretty wild. There's investors who make and do investments based on that lunar cycle.
There's
pretty crazy.
A political anecdote, probably the most charming example of crying wolf too soon, where Nancy Reagan used an astrologer to set up state dinners. And I've heard Phil Plait, he's a well-known astronomer, he uses that in his book as probably one of the lowest depths he's seen politics sink to. And I feel like if he wrote that in 2020, he'd have maybe some different points to hit on. But anyway, nevertheless, it has made its way into not only pop culture, but a lot of areas that you would think are past that. I was at a doctor's office a couple of years ago, and the doctor just said something about, oh, you have allergies this time, you must be an Aries or something. And I was just a little surprised to encounter that from a medical professional.
Yeah.
And I don't know how serious a lot of people take it. I do think it would be fascinating to talk to someone that's actually been involved with it. If you've ever heard of Penn and Teller, they have a show called Bullshit, and they debunk all sorts of modern myths and urban legends. And they have an episode on astrology that's really interesting. They follow a couple people around to different astrologers and have them read their horoscopes and just see what they come up with. And you won't be surprised to learn that they don't agree. Most of it is wrong or just blind guessing, and yet they still at the end view it as a favorable experience. They say that they actually felt like they learned something about their lives. They feel optimistic about the future. Things that aren't necessarily wrong, but the method used to reach those conclusions is questionable at best. So it's very fascinating.
Yeah. Any other questions?
What do you think a flat earther, or for that matter, any citizen, what do you think they will start thinking if they are able to travel up to the International Space Station? If SpaceX starts allowing citizen travel, people will start to kind of see outside of, an Earth perspective. And I feel that science will be much more appreciated at that point.
Yeah, I've actually heard this conspiracy theory that like the flat Earth movement is just a way for them to get the first ride, one of the first rides up on the privatized space. But there's actually videos like I followed on YouTube. I follow this guy Simon Dan on
Oh, yeah.
YouTube, and he does this Flat Earth Friday thing. Every Friday he posts these videos, like criticizing flat Earth videos and stuff. He's an interesting guy. But anyways, he recently had a gentleman who switched. He was he believed in the globe, and then he went flat Earth, and then he went back to globe, and he was like, hey, can you talk about your journey through this and like what got you to change and all this stuff. So there's stuff out there if you're interested to read.
I actually watched that, and I thought it was fascinating to hear someone talk about coming back from that kind of belief. And I think that there were some really interesting psychological factors, and there's something special about belonging to a group that claims to have privileged access to knowledge about the world. I mean, that's been a known. I mean, that's limitlessly enticing. And when you feel like you're part of a tight-knit group that will accept you at all costs, that tends to be a common thread amongst groups that have extraordinary beliefs. And I remember him mentioning a little bit about that, how it just felt like there's this overwhelming sense of belonging that you get almost without earning it. You just show up and say, yeah, the Earth is flat. And suddenly you have hundreds of people that will listen to anything you have to say without challenging it. And you feel like the sense of belonging covers for a lot of the lapses in reason that get you there. Mm. But it's, I've heard sociologists describe this as it's common in cults as a high cost initiation ritual. The more cost it is to your personal self, either in terms of reputation, finances, convenience, or just any other source of your life energy, that means that you have a much higher acceptance and stronger sense of belonging that serves as a diversion in a lot of ways. You don't feel like you don't even want to examine the beliefs too closely for fear that the group might disappear with them. And yeah, it really is a fascinating belief. If you look at it from a more stoic academic stance, there are very few merits to any of the claims. I've looked into flat Earth a couple of times just to see what they're believing, and you really can't find any two that will agree on honestly even the premise, that other than that the Earth is flat. They don't agree how it's flat. They don't agree how they came up with it. They have all sorts of mutually conflicting or just outright contradictory supporting evidence. Strangely enough, for one of our blog posts, I just did a quick blurb on flat Earth and the Eratosthenes experiment. And I was actually looking, one of the ways you can challenge if you're on there's actually a great book called Flatland. And one of the thought experiments is if you were on a plane and a creature that could only experience 2 dimensions at a time, so you could see left and right, but you couldn't see up and down with that, how would you be able to tell if the surface you're standing on is flat or curved? A simple way is to measure a triangle on the surface. So, when you measure any standard triangle, it adds up to 180 degrees. And if you think about on a globe, if you start at the North Pole, you go straight down to the equator, do 90 degrees along the equator, then 90 degrees back up, you're right where you started, but you did 3 90-degree turns, and that was over 180. So you could test if you came up with a triangle that got you back to your original starting point, having only made 3 turns, then you would know the surface is not flat. You couldn't necessarily tell what kind of curve, but you could say it's definitely not flat. So I was looking for actually, to save myself the effort of drawing the spherical coordinates, I actually just Googled the spherical coordinate terminology. And of all places, it took me to a flat Earth page using a diagram from a math textbook with the exact graphic I needed. So I thought this is kind of interesting. Let me read a little bit more. I looked through their whole page, and all they said was, they call scientists globers or globists. I think it's like globe elitists. I don't know. So
Globetards.
Globetards, yeah. Yeah, flat earthers. We have offices all over the globe.
Yeah. That was on their homepage. They changed it. It's real.
You can't make this stuff up. So I read through their argument, and they basically just said that scientists use this picture to say that the Earth is round, and then the only evidence they had to debunk the spherical coordinate derivation was that, and I quote, "It's only a picture." That was it. So it's just paper thin reasoning, and I don't even understand the logic behind that, because everything on their website is diagrams and graphics showing their point. But then when you have a very, very sober diagram explaining a very testable claim, then they just dismiss it as only a diagram or only a picture. And it's cherry picking ideas that work for you when you find it convenient, and then dismissing the rules of the game once you find it not convenient. So
I don't know. I think that they're getting too much attention.
yeah,
Because it's such a crazy claim. It's kind of like, when you have, a politician or a president, making crazy claims. It's just so crazy that they get a lot of attention from it, but it's
I
just
do
stupid.
it's easy to reinforce the noise with attention. And for that reason, I don't know that I would think there's a lot of value in debating a flat earther or these claims that have been, I guess by the time you've got to the point where you've decided that you are going to dismiss a mountain of evidence to even explain the basic premises of the world around you, and you've decided that I don't even need to do the basic homework to even understand what I'm talking about, it's just not worth anybody's time to, I'm not going to be able to reason someone out of that, because it's more about, I think, the attention of saying something that's at face value absurd, more than it is about seeking a better understanding or truth claim about the world.
Yeah, it's all very interesting. Like I said, I've been trying to reach it for a year, and actually, I can't remember the exact year, but it was a few years ago. The Flat Earth, the conference was actually held in Fort Collins a couple of years ago.
So Freddie, when you were presenting earlier without Aric, there was a video that would not play. Is there a way to open that up in another tab?
Oh, Aric,
and
can you try it?
Share that?
Hey, Aric, I tried to play that music clip. Oh, I think he went off. Yeah, let's see if Aric can do it.
He's muted.
Yeah, I think he went to go do something.
But yeah, I can see maybe if it's embedded, maybe it's not working, but if you open it up as another tab, then when you share the screen, you just choose that other tab, maybe?
Yeah, Eric's sharing right now, so I can't. Oh, there he is.
Oh.
Sorry.
Hey, Aric, can you test that link of that symphony? It didn't play the audio. Yeah, it played the video, but not the audio.
Oh, okay.
Yeah, I can't hear it.
Yeah, I can't hear anything
yet. Yeah, I just did.
Can you hear that?
Not very good.
Yep.
Oh, there we go.
I can't hear you.
Can you hear me now?
Yeah.
Yes.
Oh, interesting. Okay.
But I don't know if you guys can see this, but the little embedded video is right behind your picture video. And so I can't see it all.
Oh, interesting.
So you can't see the video?
Well, I can see a little bit, but the speaker, whoever's speaking, their picture video is kind of on top of it, blocking out some of the video.
That's odd because I can see it, but it's just really small.
Yeah.
Oh, I think it might be different for just depending on your screen size and how it orients it. Yeah, that clip, that's a whole very interesting performance. That's Holst's Planet Suite. So Holst was an English composer. I'm sure you've probably heard a lot of music from it. It's very popular, and it served as kind of the basis for Star Wars. John Williams referenced it a lot. So each movement of the suite was designed, or basically a representation of the mythology for each planet. So Mars, the bringer of war. We talked about Mars, the Greek and Roman Ares, god of war, and the associations with blood and anger and all that sort of aggression. Holst basically tried to encapsulate what he felt the essence of the mythology was in the works. So Mercury is named after I believe it's the Greek god, the messenger god. Mercury was known to be, we know now it's the closest planet to the sun. But before we knew that, we just noticed that it moved by far the fastest in the sky. And so the depiction that Holst did in the suite is that it's just this very fast, flighty, crazy movement. And it's, in ancient mythology, it's often portrayed as the winged messenger. He has sandals or shoes that have wings on them, and he can fly. Venus is often associated with the goddess of love. Venus is also called sometimes the evening star. And it's usually the brightest, when it's visible, that is. It's the brightest object in twilight, the first star, you could say, to come out. Even though it's a planet, it's so bright that it will outshine everything in the sky. And actually, at its peak brightness, it's brighter than all the planets or stars. It is the third brightest object in the sky after the sun and the moon. Other interesting things like Mars, we knew the color, so that's where it got its association with war, and that's what's being depicted in the Holst suite. Saturn is the furthest visible planet without a telescope, and it moves the slowest because it's the furthest out. It takes about 15 years to go around, and because of that, it's kind of associated with the passage of time, or the god of time. So in Holst's suite, he calls Saturn, I believe it's the bringer of old age. And it's very creative depiction of it. I'd recommend listening to it. It's about 40 minutes. It's actually fairly popular, so it gets programmed all the time with symphonies. So if you ever see it, I'd recommend checking it out. Great little tie-in with the arts and science. Also, this was written before Pluto was discovered. So curiously enough, there's no Pluto movement. Now, we know that, thanks to Neil deGrasse Tyson and all them, Pluto was a planet. Now it's considered a minor, or is it a minor planet or dwarf planet?
Dwarf planet.
Dwarf planet? Okay. It's been downgraded. And so there was a British composer, back in the, I think, 2000s. He wrote a movement to kind of posthumously complete the set and round out all the planets. So by the time he got it published and everyone was performing it, then Pluto got downgraded. So now the whole suite as it is technically complete. But again, it's all arbitrary definitions.
Yeah, another thing too is that when New Horizons went out to Pluto, then they found out that it is tidally locked with Charon, one of its moons. And they were like, and it has 2 moons, or I think even more, I forget, but it has multiple moons. And they were like, oh, maybe it is a planet.
I forgot about that.
Yeah.
So that's why the last movement is optional.
Right.
Depends on whether you think it's a planet or not.
Here, let's see. We can, what I'm showing you here is actually, this is imaging, I believe, taken from New Horizons, and it's used to map out the surface and simulate it. So this is
I think any picture of the surface is New Horizon.
So this is in theory I think this actually is imagery from the spacecraft. So this is what things would look like from the surface of Pluto. To go back to your earlier question, Cheryl, we could even see what the Earth looks like. So let's center it. Oh, we have to hide the horizon. Okay. So there's Charon.
So that's a moon. Okay, that's a moon of Pluto.
Yep.
Yeah.
I can't remember. Charon is another Greek god.
I believe it's the escort to the underworld.
Oh, across the river Styx or something.
Uh-huh.
Okay.
Oh, and it's funny, Pluto has another moon called Styx.
Oh, does it?
Makes sense.
Yeah.
Well, and Pluto is the god of the underworld.
Oh,
So
okay.
Chiron is one of his escorts, and Styx is the river.
That okay. That makes sense. And you know, Pluto was it's the furthest planet at the time when Clyde Tombaugh found it. So it was cold and icy, and I think it would make sense to assign it some sort of mythological association with the distant world.
Yeah, they say so far 5 moons have been discovered on Pluto.
Oh wow, okay. Here, let's just do a quick simulation since we're thinking about it. What we're looking at right now is the Earth as viewed from Pluto's surface. Oh, that didn't look right. Oh, here we go. Okay, so yeah, we're hovering right above Pluto and off in the distance. Kind of how we see Mercury move, just not very far on either side of the sun. That's how the Earth would appear to move from Pluto.
And where are you saying the Earth is in this? The little green thing in the middle, or?
Yep.
Okay.
So
That's
yeah,
the
the
sun.
green line is the orbit of the Earth.
Okay.
We're just vastly speeding up here. Yeah, and you see how the sun moves against the background stars? That's because the orbit of Pluto is it's revolving around the sun.
So is
It's
that
heavy,
the illumination of the sun? That's the only brightness you would see from Pluto?
Yep. That's where Carl Sagan's famous quote about the pale blue dot came from, because I think it was that image sent back, was it Voyager or Voyager 2?
Yeah,
it basically
Voyager.
pointed back, yeah, and took a picture of the Earth from just a long ways off. And the sun is not very bright at all from this far away. The solar panels on spacecraft are really not able to pick up enough energy for most of their tasks. So you have to have a different power source or thermal battery of some sort. But yeah, the Earth, you can't make out features from there without exceptional optics, and it just looks like a blue, mysterious planet. You know, when you look at Neptune and Uranus through a telescope now, that's all we see too. I mean, they're much, much larger than the Earth, but they just look like these faint little blobs. You can pick up a little bit of blue color, but they're hard enough to detect that even with a good quality telescope, the only way you can really verify for yourself that you've made an observation. Oh, there's a comet right there. What you do is you set up on the star field and you use very accurate star charts to make sure that you're aligned in the right frame. And then you plot it out and sketch where you think Uranus or Neptune should be. And then you just do this over several nights, and you'll see if one of those objects starts to move, then you know for sure that you've seen it. It's never a perfect match, even with computer software like this. When you're trying to simulate a frame, like when I go to the observing indicators here, I can set up, let's just simulate an eyepiece here. It doesn't want to do that. I can, let me try that. Well, anyway, you would normally see crosshairs here. I think it doesn't want to work from Pluto. But what you do is you simulate exactly where you know it's going to be, and you print out multiple the pictures at different scales. So really wide, then you use a tighter eyepiece and narrow it in and make sure the stars overlap, and you center it on the stars that you're expecting. And the computer is great because you can mirror it and flip it so that it matches exactly how you're expecting it through the eyepiece. And you can do some quick calculations based on your location, how much, like how the weather is, light pollution, and you can more or less match the number of stars that you'll see from, like predict which ones will be washed out because of the weather or light pollution. So that way you limit it only to the stars that you would expect to actually see through the telescope. But there's some uncertainty in that process. And so there's always going to be a few more on the chart than are actually showing up, and vice versa. So when you're looking for a planet, really the only way to be sure is to make sure that it's one that keeps moving night to night. And then you can confirm that you've seen it. I've never actually gone through the full process. I've tried several times, but never had a consistent window to knock off Uranus and Neptune. So that's on my list, and maybe we'll do that in person someday.
Well, I need to interrupt here. It's almost 5 o'clock. I can't believe time went by so fast. But this was an awesome presentation, and I really feel like I appreciate what our ancestors did with astrology / astronomy back in the day. It was really a meaningful effort on their part. And even though astrology doesn't mean a whole lot to me today, I think I have more appreciation of what it meant in the past.
For sure. Maybe we'll just end on this real quick. This is a 3D model of the New Horizons probe that we've been talking about. There's a lot more.
So this is now out of our solar system, correct?
I think it finally left. No, Voyager left. This guy's still. So we call our heliosphere, and I think Voyager has left the heliosphere, but I don't know if New Horizons. I think they're still like in the Kuiper Belt, okay, or the Oort cloud. One of those. They're somewhere over there.
Yeah,
but I think they still have a mission. So their mission's not done. I think they're still looking for another target. So, but it'll take decades to get there. But I think they're still looking for another target.
What Freddie's talking about is here's the sun, and then the planets are all in there, and then there's this big sphere of debris that orbits our solar system. So it's the next thing you would get as you're leaving the solar system and headed for interstellar space. I actually don't know the Roche sphere's significance.
So I think the Roche sphere is like the sphere of influence of our sun.
Okay. So that's where if debris crosses inside that boundary, it gets interacted.
Caught by the sun.
Yeah, pulled in. Okay.
Yeah.
Yeah. So all of our like spacecraft, even the furthest ones out, there's see the Kuiper Belt, the heliosphere. This is what he was talking about. All these different layers, and then the innermost one is the planets here, and that I think is I think that's Uranus's orbit right there.
Yeah, I haven't followed New Horizons too much, but I don't know exactly where they're at. But I know Voyager and them. It was a couple years ago. They hit the heliopause, but then that has some width to it, which is the boundary between the heliosphere. And I don't know if they made it out, and that would technically be interstellar space. But yeah, I off the top of my head, I don't know.
Space is big.
I haven't checked on that. Yeah, I haven't checked on Voyager and them in a while.
Yeah.
So I don't know if I shared with people when we started, but Freddie and Aric are going to be a reoccurring speaker for us. So maybe every month to 6 weeks we'll bring them back, and some really interesting discussions and topics for the future. So thank you guys very much, and I think we should let people go and enjoy the rest of their Sunday.
This was great. I really, really enjoy it. Thank you guys very much.
Thanks for having us.
Thanks.
If you have any questions, please feel free to reach out. You can email us anytime. We're happy to answer questions, or if you have ideas for next time that you want to hear specifics, we're more than happy to look at that.
Great.
Yeah, if y'all have, sure. I don't know if you want to get some topics together and then shoot us over, see what y'all want to talk about.
Well, Aric has emailed me two topics that I think are interesting. One about the misconceptions in movies. So I want to do that one. And then one that was something with Galileo and Copernicus and those guys. I can't remember what the topic title would be, but I've got 2 planned on the calendar. I'll let you know when the next one is coming up.
Keep us posted. Thank you.
And no,
Yeah.
thank you guys.
Okay. Thank you
Next
guys.
time.
We'll
Yeah.
see you
Have a
later.
good
Bye.